Before we get started on actual notes tonight, I want to take a couple minutes to look at our next couple of class days, just so that we can all be on the same page about what our expectations are. So here we are at the end of module 2 and coming up on your first test. So on Wednesday, we are going to do a test review together. That means that you don't have a video lesson for Wednesday. So there's no video lesson to watch to prepare for Wednesday. Just come to class and we're going to do this in-class test review together. Now, there are 2 other test reviews here, so I want to address them both really quickly. This written test review is not collected, will not be graded. It is just for your practice. But of the 3 things here, this written one is the closest to your test. Okay, so you can do this on your own. Again, here's your answer key so you can do your work and then check your answers. And if you're not sure, if you got something wrong, if you need my help on it, feel free to ask. But I'm not grading this. So just because I'm not grading it doesn't mean I won't answer questions on it, but you're not handing this in to me, okay? And so then this third review is a review and more that I made that is extra credit, because if you've gotten to this point and you've done really well on all of your homework assignments and you go through this review and you're great, and you go through this review and you're great, then I don't really know that you necessarily need this review, but I put it there as a way to try to motivate you to do a little bit more to prepare for your test. So this review is extra credit towards your homework. Okay? And then your actual test will be available to you starting on Wednesday, and it will close the following Tuesday. So it's available from the 24th until the 2nd. Now, I have not scheduled anything for us for Monday the 1st, because I know that sometimes finding time to sit down and take a test can be difficult. So what I did was I purposefully did not schedule anything for this class period so that if you need that time to take your test, you can have it. Now, just to be clear, that doesn't mean that you have to come into the meeting to take the test. You absolutely do not. The test is not proctored. You do it on your own time. I will be here, and if you have any questions or you want to double check something with me or you need something reopened or whatever, then you can pop into this meeting and we could just chat. But know that Monday's class is not mandatory. It's just me giving you a block of time to take your test. And I will not be doing any formal review or any formal lesson on Monday. I will just be here to answer questions if you have them. So again, no real class on Monday, but feel free to pop in if you need help or you have a question about your test. Okay? And then while we're talking about it, let's look at the test and let's talk about the settings. So first of all, that's clearly wrong. That's from last semester. So let's fix it. There we go. So the first thing that you have to do is do this submission agreement, and the submission agreement is basically just you saying, okay, I promise not to cheat. So say you just like, by submitting this, I agree to abide by the honor code. I agree, I understand, and then submit. And then you'll get 100% on this submission agreement. And then once you have 100% on this submission agreement, then your test will unlock. But you will not have access to your test until you complete the submission agreement. Once your test is available to you, you have 4 hours to complete it. So let me be clear on that. You don't have 4 hours from the time you submit this. You have 4 hours from the time you open this. So from the time you first go into this exam, a 4-hour timer starts, and you have 4 hours to complete it. There are 10 questions, so it's definitely doable within a 4-hour window, but I would still give yourself the full 4 hours just to be 100% safe. So make sure that you do not open this until you are positive that you will have the time to finish it, because I can't extend that time for you. So like if you come to me and you say, oh my God, Jess, I was working on it and then I don't know what happened, but blah, 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 then there's nothing I can do. I literally cannot extend it for you. I don't have that option anymore. So I need you to be 100% ready when you sit down and take this test. The other thing that I want to be clear on is that short of a serious and major emergency, I will not extend your deadline for your test. So I give you like a full day's worth of class time to work on it. It is open for a week. You have 7 days. At some point in those 7 days, you need to sit down and take this test. Do not wait until Wednesday and then have your internet go out and then come to me and say, I don't know what happened. My internet went out. Well, you waited until the last day, or Tuesday, I mean. You waited until the last day. So I don't know what to do for you now. Okay. So try to get it done sooner rather than later. Don't wait until the last minute. And know that if you do have a true and honest emergency, like last semester, I had a dude who, like his wife wound up in the hospital for a week, and of course I extended his test. But if it's that you planned poorly, then no, I'm not going to extend your test. Okay. So you only get one submission. So once you put in all of your answers and hit submit, it will be submitted for grading. You will not see your score until I'm hoping Wednesday. I'm hoping if you guys finish it on Tuesday that I can grade it on Wednesday. There's a little bit of work that goes into that for me that I'm going to talk to you about next, but there are 110 points available, but it's only going in out of 100. So there are 10 extra credit points available on this test. So let's say you got a 94 out of 110. While that is technically an 84%, 85%, I will put it in as a 94 out of 100, which is a 94%. Okay. So there's some extra credit built in. Okay. And then I want to talk about this real quick. So you do have one question on here where you have to submit your work. The questions will be different for everybody. So like, anyway, I don't want you being like, oh my God, she's showing us the test. No, when you open it up, your test is going to be different. So for one question on the test, you're going to have this right here, load a picture of your work. So you're going to have to take all of your work from this problem, take a picture of it with your phone, and then use this insert image, upload, and then find it on your computer and upload it right here. Okay. So my recommendation to you is that at some point before you take your test, take a minute and make sure that you are comfortable getting pictures from your phone to your computer, because doing this like as you're trying, when you have a 4-hour limit and this is your first time and you're taking your test, you don't want that to be the first time that you've ever had to move a picture from your phone to your computer. So if you've done it before, awesome. If you have never done it before, if you've never gotten a picture from your phone to your computer before, my recommendation is to take a picture with your phone and then email that picture to yourself. That way you can get it from your email on your computer. But again, I would absolutely practice that at some point before you take your test so that you are comfortable getting a picture from your phone to your computer when you sit down and take your test. Okay. I feel like that's everything I wanted to say. Like I said, it's only 10 questions, so you probably won't need the full 4 hours, but I would still block that time out just to be 100% sure. Okay. Does anybody have any questions about your test before we get started? Okie dokie. So let's take a look at 2.3, 2.4. Okay, so here at the beginning of 2.3, we have this problem that says that we want the point of intersection between these two lines. So to find that point, I'm going to set these two equations equal to each other. and I'm going to solve. So anytime I have an equation like this with a bunch of fractions, the best way to solve it is going to be to multiply everything from left to right by the lowest common denominator. So here, the lowest common denominator is going to be 10. So I'm going to multiply everything from left to right by 10. And the reason why we do this is because when we multiply everything from left to right by the lowest common denominator, we eliminate our fractions. So here, 10 times -3 is -30, divided by 5 is -6. This 10 and this 10 cancel and leave me with a 21. 10 times 6 is 60, divided by 5 is 12. 10 times 66 is 660, divided by 5 is 132. And so again, multiplying everything from left to right by the LCD eliminated all of my fractions. So now I'm just going to solve this. We'll add this 6x to both sides. Oops, that should be an 18 now. And we'll add the 132. And then we'll divide by the 18. Remember, math enter to convert a decimal to a fraction. And we have x is 17/2. And then once we have that x value, we plug it into either one of these equations to get y. So -3/5 times 17/2 plus 21/10, -3. And if you want to be 100% sure that that answer is right, if you take this 17/2 and plug it into the other equation, you should get the same thing. Oops. See how when I plug in 17/2 to both equations, I get the same y value? That means that it is the point of intersection. That is my answer. Okay, so for the next one, here we have home values in Indiana and Minnesota, and I want to know if these values are changing linearly. In which state have the home values increased faster? So I'm going to think of 1950 as my 0 year. We're going to say that's the year where it all starts. And then 2000 as my year 50, because it's 50 years later. And so if they're asking me about the rates, then that means they want me to compare the slopes. So first, let's find Indiana's rate of change or its slope. So that would be 94,300 minus 37,700 over 50 minus 0, 37,700. So in Indiana, the rate of change is $1,132 per year. Now let's do the same thing for Minnesota. 122 I'm going to guess that Minnesota is going to be higher only because there's a much bigger difference between these two values than there is between these two values, but let's double check. 2,400 minus 47,300 divided by 50. So then in Minnesota, I get the change is $1,502 per year. So which state has a higher rate? Well, that would definitely be Minnesota. If these trends continue, what would the median home value in Indiana in 2010 be? So we can write an equation for Indiana based on this slope. And this as my y-intercept. Because once you have the slope and the y-intercept, you have your y equals mx plus b. Now, my 0 year is 1950. So then that means 210 would be 60 years later. So 210 would be when x is 60. So that would be $105,620. And so if we assumed the trends continue, what value will the years be equal? All right, well, we have an equation for Indiana, so we can do the same thing to write an equation for Minnesota. The slope was 1502, and the initial value was 47,300. So here, I'm going to do what I did on the question before this, and I'm going to set them equal to each other. So 1132x plus 37.7 equals 1502x plus 47,300. So let's subtract this 1132x. And then we'll subtract the 47,300. And we'll divide by the 370. Okay. So, I feel like I want to tell you, so this is 25.95 years later. I want you to count back then because my initial year was 1950. So if we count back by 25 years, then we would be at 1929. So I'm honestly not sure whether Moore is going to want 1929 or 1924 because of this 0.95. So I'm going to say 1924 because that's what I think the right answer is. But know that if that's not what Moore wants, then I would change that to 1925 and see if that works. Okay. All right. Phone company AT&T has a monthly cellular plan where the customer pays a flat fee of a certain amount and then money per minute. Okay. So if you use 400 minutes, you pay $74. And if you use 740 minutes, you pay $108. So we've done a couple of these together now. Anytime you have 2 points, you're always going to start with the slope. So that's going to be 34 over 340. So my slope here is going to be 0.1. And then once you have the slope, you take the slope and either point and plug into point slope. So y minus 74 equals 0.1x minus 400. And then we're going to solve for y. So let's distribute this 0.1. And then add the 74. Now they want c and x, so this would be c of x equals 0.1x plus 34. Okay, so then 892 minutes, I'm going to plug in 892 there. So then 0.1 times 892 will be 89.2. 89.2 plus 34. No. So it would be $123.20. Okay. A moving truck rental company charges $23.95 to rent the truck plus 80 cents per mile. So the equation for this one, that is my slope and this is my y-intercept. So this would be c of x equals 0.8x plus 23.95. So anytime you have a base fee plus a per something, that base fee is your y-intercept and your per something is your slope. So here we would say C of, they want 45. So C of 45 equals, and then we're going to plug in 45. $59.95. And then here they're looking for units. So your choice would be dollars. Because if you drive 45 miles, it will cost you $59.95. If you have $85 budgeted to move, well, your C was your dollars. So 85 equals 0.8x plus 23.95. So let's subtract that 23.95. divided by the 0.8. But they want you to round to the nearest whole units. So this would be 76 miles. So if you can afford $85, then that means you can travel 76 miles. You're choosing between two different cell phone plans. The first plan charges 25 cents per minute. The second plan charges a monthly fee of $39.95 and 10 cents per minute. So I want to know, at what point is this less than that? So we'll start by subtracting the 0.10x. And then we'll divide both sides by the 0.15. So when x is greater than 266.3, so that means it would be at 267 minutes. You have to be greater than 266.3. You can't say 266. You'd have to say 267. And so then 2.4 was about linear regression. So the first thing that I want to talk to you about is the idea of a correlation coefficient. So the correlation coefficient tells me how well related the data is. If you have a correlation coefficient really close to, so your value is always going to be between -1 and 1. A value close to 0 means that there's no relationship. A value close to -1 means that there's a strong relationship and that your dots are decreasing, that your function is decreasing. So as your x goes up, your y goes down. A value close to +1 means that your dots should be close together and increasing. So as x goes up, y goes up. And then the closer you are to 1 or -1, the closer your dots should be to one another. So for example, here, my dots are pretty well clustered around one another and they are clearly increasing. So I'm going to say that my correlation coefficient for this one would be the 0.82. And then here, my dots are not quite as close as this one, but they're definitely decreasing. So I'm going to call this one the 0.76. Now for the next one, the dots are all over the place. So I'm going to say that one's the 0.04 because it's really close to 0. There's no discernible pattern there. And then for the next one, I would say that -0.21 because they are going down. Like you can sort of see that they're decreasing, but they're not really close together. And so then for this next one, they just want you to put your dots on here. So 13, 7, 25, 22, 30, 25, 32, 32. So more is pretty forgiving. So as long as you're in the right neighborhood, you're going to be okay for these. 37, 32. I don't know if you can hear what's going on behind me, but my toddler is mad about something. 39, 39, 48, 40. And then when you put in your line of best fit, just try to make it go in between the dots as best as possible. So you want to try to get the same number of dots both above and below your line. And again, more is pretty forgiving. It will definitely give you a margin of error there since it knows that you're just estimating, but still try to do your best. All right. And then last but not least, this is a proper linear regression question. So here we're measuring T, the number of thousands of statewide registered automatic weapons, and P, the number of murders per 10,000 per 100,000 residents. So before we do anything else, if you have a TI-83 or a TI-84, before you do anything else, I need you to do me a favor and press second and then 0. And then scroll down until you see diagnostics on. Diagnostics on. Press enter and then enter one more time. If you don't turn your diagnostics on, you're not going to see your R values, and then this is not going to be super helpful to you because you won't be able to complete this question. So make sure you turn on your diagnostics and then go to stat and then enter for edit. If you have something in these lists, just press the delete button over and over again. You're going to want to make sure that you don't have anything in L3 either. Make sure all of your lists are empty. And then your top values are going to be your inputs. So 11.3, 8.2, 6.9, 0.7, 2.8, 2.6, 2.4, and 0.9. And then your Y values. Okay. I always just like to take a second to make sure they're right. Because if they're not right, then your answer is not going to be right. Okay, there we go. So then we're going to go back to stat, over 1 to calc, and then down to 4, linear regression, AX plus B. Make sure this is L1 and this is L2. Make sure your frequency list is blank. You don't need to worry about that last one. Okay. So if your A is 0.859 and your B is 4.08, they want 3 decimal places, so 4.084, then your equation here would be P of T equals 0.0 or 0.859 T plus 4.084. My R value is rounded to 3 decimal places, 0.999. And my R squared value rounded to 3 decimal places is 0.998. Okay. And so then it says, using linear regression, how many murders per 100,000 residents can be expected in a state with 9,200 automatic weapons? Okay, 9,200 automatic weapons. Well, the question says thousands of state registered automatic weapons. So then 9,200 would mean that T was 9.2. So then I'm going to plug that in. So 0.859 times 9.2 plus 4.084. And so to 3 decimal places, we would say 11.987. And then how many automatic weapons would you expect in a city with 8.7 murders? So 8.7 murders were my p-values. So 8.7 equals 0.859t plus 4.084. Let's subtract that 4.084. And we'll divide the 0.859. So I got but remember how here we turned 9,200 weapons into 99.2. So we have to do the same thing here and say that 5.3736 would be 5,373.6 weapons. They want it rounded to the nearest whole, so let's say 5,374. Okay. That's it.